we're looking for measures of center. That's what the mean, median, and mode are all doing. There are three different types of identifying the center of a data set. Okay. Whenever you're doing the mean, that's like the average, where we take all of the numbers in the data set and we add them together. And then we divide by n. So n is the number of values in the data set. And then the x1, x2, all the way to xn, that's your list of values in the data set. So that's your list being added together. So it's the sum of all values divided by the number of values. And we've done that before. That's not anything new for us, hopefully in AGS3. But that's what a mean is. Median is where you need to list the numbers from min to max. And then you literally find the middle number. Okay, so it's the median of n numbers is the middle number when the numbers are written in order. So if n is an even number, then the median is going to be the mean of the two middle numbers. You would take the two together, add them together, divide by 2, and you'd find the median. And we'll take a look at an example like that today too. And then the mode, that's the last one. So let's say median here is in green, mean is in black, mode we'll do in blue, and that's the number that is occurs the most frequently. So there may be one mode, there might be no mode, or there might be more than one mode, which is all possible. But basically, if you have a data set and you have one number listed 4 times, everything else is listed once, then that's what we would do here. Is we'd say the mode is the one that's listed the most times. So key for the stats unit is just to make sure you're showing your work. Like when we get to our quiz, we're going to have a grade assignment, we're going to have a quiz. When we get to our quiz, make sure that you show your work. So, for example, when we're calculating the mean and we're looking for, this is the data sets of people in waiting times at the veterinary's office. We want you to find the mean, median, mode of each data set. So when you're finding the mean, show your steps. So, for example, what we'll do here, and there's a couple reasons why we want to do this, and we'll talk about that too. But when we're doing the mean, I'll do it in black actually, because that's the color I did up above. We can say 14 plus 17 plus 18 plus 19 plus 20 plus 24 plus 24 plus 30 plus 32. I do this for a couple reasons. One is I want to make sure I got all the data points. So it should be 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I can count it down here as well. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. So I've got them all written down. That's the first reason we want to write it down. And then second is we can add it all up and we'll get our sum at the very end when we add all of these numbers together. And we'll want to write down that sum divided by 9 before we actually do the division. And in this case, we end up getting 198. Okay, that's our mean. And we're actually going to represent the mean, I didn't talk about this yet, by using this variable x bar. It's actually pronounced x bar, but it's going to be an x with a bar over it. That's how we're going to actually write down the mean. So this comes out to 198 divided by 2, which comes out to 22. All right, so that's our mean. That's how we calculate the mean of this function. Okay. Yeah, so I want you to show your work for this, like when you're doing the mean, just write it all out like this, and then show the next step where it's actually summed up. And the reason is because if we decide to add a data point later, like let's say there are 9 points, and then I say, hey, a 10th person came in and their wait time was 26 minutes. What's the new mean? Well, all you have to do is do, oops, I have 198 divided by 2 here. That should be 198 divided by 9. If I have this written out like this, then all I would need to do is say, okay, I'm going to add 26 to 198, and I'm going to divide by 10 instead of divide by 9. So it's really easy to make that adjustment if I have this written out. Otherwise, if I didn't write anything out, then I'm going to have to enter all 10 data points in my calculator and sum them up again. So it's trying to save you some steps. That's why it's important to do this. We're actually going to do an example like that in just a minute here, where we will need to add another data point. So it'll be nice that we have this written out. Now Office B, find their mean. They should have 8 points as well, or 9 points as well. 8, 11, 12, 16, 18, 18, 18, 20, and 23. And we'll make sure there's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. All right. And then for this one, we end up getting 144 divided by 9, and that comes out to 16. So our mean for Office B, the mean wait time, is 16 minutes. A little better than what we had for the wait time for Office A. Median, that's where we want to find the number that's right in the middle. So there are 9 numbers, so I could count in from value 1, 2, 3, 4, be the 5th one in. If I know from the other side, it'd be 1, 2, 3, 4, 5th one in. So the median is going to be 20 for Office A. And for Office B, it's going to be 18. Same thing, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, and then the mode, the most frequently occurring number. In Office A, 24 occurs twice, and in Office B, 18 occurs 3 times. There are 3 18s written down in that data set. That's how you identify the mode. All right, so this is something we would have done in AGS1. All right, so maybe you remember it, maybe you don't. Not a big deal. I don't think it's a crazy difficult topic, so just hopefully we can get you back into the mood of it, because this is just the very beginning of our stats. We're going to talk about standard deviation in a minute, and that's what's a little more difficult, in my opinion, to calculate, but still not crazy difficult. We can break it down and make it pretty easy. Okay, then the next part, we're talking about a measure of dispersion, which is, it tells you how far spread out your data is. So typically we want to know how spread out our data is because it's going to help us determine things. So we'll look at the range here. And the range is always going to be the maximum value minus the minimum value. That's how you always calculate range. So in Office A, the maximum value was 32 minutes. The minimum value was 14. And we end up getting a range of 18 minutes. In Office B, the maximum value was 23 minutes. The minimum value was 8. And we get a range of 15, which tells us the difference between the shortest wait time and the longest wait time was 15 minutes. That's at Office B. And at Office A, the difference between the shortest wait time and the longest wait time was 18 minutes. All right, that's what all this information means. Okay. Another measure of dispersion is standard deviation, and this is the last big thing we're going to be talking about today. So when we talk about standard deviation, it's this equation right here, and standard deviation is represented by this symbol here, which is read as sigma. It's a Greek letter sigma. All right. And the way you calculate standard deviation is it describes the difference between each value and the mean. So that's what we're doing here. We're taking each individual value and we're subtracting the mean from it. And then we're squaring that result. We're going to add them all together. We're going to divide by n, and we're going to square root, which looks really scary, but honestly, it's not too bad. So in order to use standard deviation, we're going to break it down into 5 steps here. First step, we need to find the mean. So let's use Office A. We already did that. The mean was 22. Okay. Now for each data point, we want to find the square of its distance to the mean. So our data set from Office A, we had like 14, 17, 18, 19, 20. So we're going to write that down first. So here's our data set. 14, 17, 18, 19, 20. There were two 24s. And then I'm going to scroll back up real quick. 30 and 32. So I'm just rewriting my data set down. I'm going to make sure there's 9 points. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. And then we're going to find the distance to the mean on each of them. Since the mean was 22, we're going to do 14 minus 22 and then square that result. And then we'll do our next one. 17 minus 22 squared. 18 minus 22 squared. 19 minus 22 squared. 20 minus 22 squared. 24 minus 22 squared. 24 minus 22 squared. 30 minus 32 squared. 30, oh, so minus 22, sorry. And then last one was 32 minus 22 squared. All right. So you do 14 minus 22, that's going to be negative 8. But whenever you square it, your answer should always be a positive number. So that comes out to 64. And then 17 minus 22 is difference of 5 squared is 25. 18 minus 22, that's difference of 4 squared is 16. And then 19 minus 22 is 3 squared is 9. 20 minus 22 is 2 squared is 4. 24 minus 22, 4. 24 minus 22, 4. 30 minus 22 is 8. And then square that number is 64. And 32 minus 22 is 10. Square that number and you get 100. That's step 2. Make sure we have 9 values. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. So that's what step 2 looks like here. I think the hardest part about standard deviation is just making sure that we're bringing all of the data along with us when we're doing it. That's the trickiest part, I think. All right. On your quiz, your next quiz, you will be asked, guaranteed 100%, you will be asked to calculate standard deviation by hand. So you'll need to be able to show these steps. There are plenty of apps and things you can do it really easily on your calculator where you just type in the data set and bam, here's your standard deviation. But I'm going to ask you to do this by hand once, so show these steps. All right, so we found the mean. Now we found each data point, we found the square of its distance from the mean. Now step 3 is we're going to do the sum of all of these values. So we're going to take our 9 values and add them all up for step 3. 64 plus 25 plus 16 plus 9 plus 4 plus 4 plus 4 plus 64 plus 100. And then there should be 9 values here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Just making sure I got all 9 of them. All right. And then it's just as simple as adding them all together. And I got 290 here by adding all 9 values together. Step 4 says divide those by the number of data points. So now I'm going to take my 290, and there were 9 data points, so I'll divide by 9. And I get 32.2 repeating. And then I'm just going to take the square root of that. And that's the last step. And I end up getting 5.676462. And we'll just go ahead and round to the nearest hundredth. We'll say 5.68. All right, rounding to the nearest hundredth would be our standard deviation. All right, so it's a lot. It's 5 steps, kind of a lot, but I think this is a lot easier working with these 5 steps than it is looking at the equation up here and trying to figure out what it's asking. A lot easier if you can break it down, all right, by those 5 steps. And what I want you guys to do is go ahead and give it a practice with standard deviation. Go ahead and find the standard deviation for office B. All right, so give office B a shot and find the standard deviation. Take a minute to do that now. I got a standard deviation of 4.50 when I rounded it. I think it came out to like 4.4967 something, but because of the 4.496, you would round it up, and that would round 2 numbers back. So we rounded to 4.50 and rounding to the nearest hundredth. And think about in context of the situation, what does that actually mean, right? We have a standard deviation of 4.5. Well, this problem started out talking about veterinary wait times, right? So if you take your pet to the vet, this is your wait time. So it's saying if you have a mean wait time in office B of 16 minutes, on average, most of the people will be seen within 4.5 minutes of that time. Either 4.5 minutes before 16 minutes, which would be 11.5 minutes after they arrived, or 4.5 minutes after 16 minutes, which would be like 20.5 minutes. So that's what it means. That's what standard deviation is good for telling us. It's telling us most of the people will fall in kind of that range of values from 11.5 to 20.5 minutes, all right, for their wait times. Okay, next example here. If you're competing in an air hockey tournament, the winner scores for the first 10 games are given below. All right. The very first thing I'd want to do with this type of problem before I do any solving is just go ahead and resort it from min to max, because that's going to help us when we're getting to the median. So starting with, like, I see 11's a low value, and I look for 12s. There's 1 12. And then I go across and look for 13s. There's 2 13s. Then I look for 14s. There's 1. And then 15s. There's 1 2 3 4. And then finally, there's a 17 here. So just start by very first thing, reorganize from min to max. That's going to be helpful when we're looking for the median. It's also going to be helpful when we're looking for the mode. And start out, I know that there were 10 data points, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because it did say the first 10 games here as well. And then I count my 10 here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, to make sure I'm using an accurate data set before I do all of my calculations. So when you do the mean, you want to add all of these together again. So 11 and 12 and 13, 14 and 4 15s, and then finally a 17. All divided by 10. And this is a good example where we want to write out what the sum is of all 10 of them. It comes out to 140. So that means 140 divided by 10 is going to be 14. So we end up getting our mean is 14 here. That's the toughest one to find. We do a median, means we got to go to the middle numbers. And in this case, there's 1, 2, 3, 4, 5. The median's going to fall right here between 14 and 15. And this is where above it said take the mean of the 2 numbers around it. So 14 and 15, you add them together, you get 29, divide by 2, and you get 14.5. You might also be able to see what's halfway between 14 and 15. Oh, that's 14 and a half. That might be able to work as well. The problem is if the two middle numbers are like 20 and 37, it's going to be harder to find that median. So that's where you want to know 20 plus 37 divided by 2, and you'll find that halfway number really fast. But in this case, the median is 14 and a half. And then the mode is the most frequently occurring number. It's going to be 15. 1, 2, 3, 4 15s that occur during this time. Way more than any other number. And then for the range, we do the max minus the min, 17 minus 11, and we get 6. Okay. Next part, we're going to find the standard deviation of this data set. So again, just make sure you're showing your work and you're identifying the standard deviation correctly. So I'm going to write it down a little differently this time than I did the first time to organize my work. And I'll start by saying 11 minus my mean squared, 12 minus my mean squared, and then there were 2 13s. There's 1 14, and then there were 4 15s. So that's going to take a while. And at the very end, when I count it, I just want to make sure that I have 10 sets of parentheses written down. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's good. And speaking of 10, all of this needs to be divided by 10. Oops. And now, when I do the next part here, I can go ahead and simplify a little bit here. 11 minus 14 is 3, squared is 9, and then 12 minus 14 is 4, 13 is 1, 1, 0, and then we have 4 of the 15s, which is going to be 4 1s. And then 17 is 3 units away, so that's going to be a 9 squared. I can simplify it and rewrite it like this. I just rewrote those 10 values once they're defined the difference and square them. And again, just make sure that I have all 10 values written down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. And now I can go ahead and calculate my standard deviation. Add them all together. 13, 14, 15, 16, 17, 18, 19, plus 9 is 28 over 10. So I'm going to do the square root of 2.8. And then when I find that square root, I ended up getting, for my standard deviation, about 1.67. Okay, all that work to get my standard deviation. But again, I want you to write this out because the big part is the next question. Now it's saying we're going to add one more data point. The team played an 11th game. This hockey team played an 11th game, and they scored much fewer. This time the winning score was 3. So before the lowest winning score was 11, now it's 3, and we have 11 data points instead. And if I ask you with this new data set, let's go ahead and calculate mean, median, and mode. Well, if the mean, I would have to start over, or I could take my old data set, which was up here, 140 over 10, and I can just say, oh, I can do 140 plus 3 over 10 plus 1, because we're adding one more point. So it's really 143 over 11. It saves me a lot of time there, instead of adding them all up again. And my new mean happens to be 13. All right, adding a new data point on at the front is going to change my median as well. Now there's 11 points, so I need to go halfway in. 1, 2, 3, 4, 5, 6. Coming from the other side, 1, 2, 3, 4, 5, 6. We end up at 14 from both sides. So that's our halfway point. 14. And then our mode, the most frequently occurring number, still going to be 15 here. There's still 4 data points that have 15. The range is something else that's going to take a big swing. It went from 6 to 14. So our range is now like bigger than our mean is. Like we have a larger range than our mean, which is kind of crazy. All right, but that's what something that's called an outlier will do to the data. An outlier is a data point that doesn't really match the rest of the data set. And that's what's happening here. Now I want you guys to go ahead and calculate the new standard deviation. So one more practice, we're using the new standard deviation. And then answer questions 2 and 3. Which measure of central tendency does the outlier affect the most? So that's mean, median, or mode. Which one do you think it affects the most? Which one does it affect the least? And then what effect does the outlier have on the overall data set? So take a minute to do that now. By the outlier, which one got affected the most? So the outlier definitely affected the mean the most. The mean dropped one whole value from 14 to 13, which wasn't a huge drop here, but it was something. And the one that actually wasn't affected at all was the mode, because the mode was 15 before, and then it was still 15 afterwards. And what effect does the outlier have? It can really change. It changes the mean, and it changes the standard deviation of the data quite substantially. So it can change the spread of your data quite a bit. All right, that's the idea for outliers there. Okay, so that covers everything for today. Tomorrow we're going to talk a little bit more about exactly what the standard deviation is doing. So today is just more like